Hi everyone, and welcome to the Aquarius webinar on Fair Data Principles. I am Sisiona from the Hellenic Center for Marine Research, and in this webinar we will have a generic overview of what FAIR principles are, what FAIR data is, then some information on the FAIR extensions, and finally we will see how Aquarius project is addressing the FAIR implementation for the collected data within the transnational access scientific projects. These are the references and data sources used for this presentation. And let's have first the introduction of what FAIR principles are. FAIR principles are a set of guiding principles to be applied to data to ensure that these are shared in a way that enables and enhances their reuse by both humans and machines. FAIR data principles apply to metadata, data, and the supporting infrastructures, such as search engines or services. FAIR stands for findable, accessible, interoperable, and reusable. The aim is to provide guidance in the process of making research data findable, meaning that data can be discovered by others, accessible, meaning that data can be made available to others, interoperable, data can be integrated with other data, and reusable, meaning that data can be reused by others. Some background information. FAIR principles emerged at a workshop held at 2014 by a wide group of scientists and organizations who wanted to remove barriers in data discovery and reuse. They defined a minimum set of community-agreed guiding principles and practices to make data more easily discoverable, accessible, appropriately integrated and reusable, and adequately citable. Since then, the principles have been fine-tuned and improved by Force 11, a non-profit community of scholars, librarians, archivists, publishers and research funders, aiming to help the change towards improved knowledge creation and sharing. FAIR principles originated from the life sciences, but they are applied to all data disciplines. In 2016, they were published in the Nature Scientific Data Journal, focusing on machine actionability. In other words, how to enable machines to automatically find and use the data, and not only the data reused by humans. But why FAIR principles are important? This is a non-exhaustive list. Many more benefits can be included. But we can summarize by saying that the adoption of FAIR data principles improves research quality, enhances the scientific and societal value of data, and leads to a more efficient collaborative research ecosystem. Thanks to the work of many initiative projects and groups to implement the FAIR principles in practice, they became very popular almost immediately after the definition and publishing. The scientific community accepted the principles and enabled them into their practices because they provide a very useful framework for research data management, which enables preservation, sharing, and maximum data reuse, especially today in the digital era of open science. The FAIR data principles are central to the Horizon Europe guidelines on research data management. And today they have been adopted by the European Commission to drive and support its open science policy implemented by the European Open Science Cloud, the EOSC. And also it is a funding requirement today for projects and researchers to make the data generated from Horizon Europe funding projects as fair as possible. In this slide, we can see some of the many European-funded projects, initiatives and networks which are working to advance data fairness and open science and contribute to the implementation of the EOSC. Let me note here that in several cases, projects like CDataNet and others started the development of interoperable data infrastructures based on common standards, tools and services long before FAIR principles became a priority, at least 15-20 years before. A small parenthesis to point out that fair data is not synonymous with open data. Open data can be freely used, modified and shared by anyone for any purpose. Is freely available without restrictions. There is no need to pay or there are no other technical barriers. Open data has open licenses, which allow anyone to use, share and often modify it, usually with minimum requirements, like attribution. Preferably, open data is provided in an open file format that can be used by anyone with a free software. Examples of open formats are CSV, JSON or XML. Fair data, on the other hand, should be accessible under well-defined conditions, meaning that it should be clearly and transparently documented how data can be accessed and under which conditions. Data which are shared under restrictions can still be fair. So, accessibility is not only related to openness, because open data may not be fair. In Aquarius, our aim is to maximize the amount of open and fair data that are going to be delivered. Let's see now what fair data is. What does fair mean? There are 15 criteria or guiding principles for how data should be managed to make it findable, meaning discoverable by both humans and machines, as we already mentioned, accessible, meaning available to anyone, interoperable, so as data can be integrated, can be combined with others' data, or can be easily and correctly used by the machines, and reusable, meaning that data can be replicated for new research purposes. It is important to say that the principles should be applied from the start of a project and throughout the entire data lifecycle, because the earlier the principles are applied in a project starting from data collection to publication, the easier it will be to keep data fair. That's why data management plans, like the ones that Aquarius will implement, are very important. You may notice that all principles are referring not only to data, but also to metadata, which, together with the standards, are very important to fairness. So, a few words of what metadata is, for those who are not familiar with it. A simple definition is that metadata is data about data. While data can be what we collect, for example, in a scientific cruise, metadata are data that will describe these collections. For example, the value 15 is data, but it means nothing. But if we say 15 is the surface temperature at a specific location, date, time and unit, then it means a lot. Metadata provide information on who measured them, when, where, how they have been processed, what is the unit, what quality control checks have been applied, etc. Information that helps others to understand, find and use it effectively. There are different types of metadata depending on their function. We have descriptive metadata for who, when, where, technical or structural metadata which describes how data are organized, what is the file size, administrative like usage licenses and so on. Remember that rich metadata are essential for making data fair. And for that reason, Aquarius will offer to its scientific teams training and guidance to appropriate tools and services for creating fair data and metadata. Let's go now to the principles themselves for what is findable data. The first step in reusing data is to find them. Both data and metadata should be easily discoverable by both humans and machines. Data should include rich metadata and assigned unique and persistent identifiers linked to metadata. Machine-readable metadata are very important to enable automatic discovery. Data should be deposited in searchable repositories. This is in summary what the 4 criteria linked with the findability are saying to us. Let's see them now in some more details. The first principle says that data and metadata should have globally unique and persistent identifiers. This principle is the most important because it will be difficult to achieve other aspects of FAIR without identifiers. They remove the ambiguity of the published datasets and can consist of an internet link, such as a URL that resolves to a web page that defines the dataset. They are often automatically generated by data repositories or registry services when we upload our data to them. The benefits from their use are they can help other people to understand what our data is about and allow computers to interpret them in a meaningful way. They are essential to the human-machine interoperation, which is key to the vision of open science. And also, they help others to properly cite our work when they reuse our data. There should be two conditions for them. They should be globally unique, meaning that someone else cannot reassign the same identifier without reference to my data. And also, they should be persistent, meaning that the link must remain available, at least to some degree, even if the resource is no longer available. A few examples is the ORCID, that is a free, unique, persistent identifier for persons, and the well-known DOI, the Digital Object Identifier, which is a string of numbers, letters, and symbols that are used to uniquely identify a resource on the Internet. A resource on the Internet can be an article, a document, a dataset. The second principle is that data are described with rich metadata, meaning that, as we already heard, that the users should be able to find my data based on the information I provide to the metadata, even without the data's identifier. There should be metadata about the context, such as protocol used, parameters, instrument, units, metadata about the characteristics, such as file type, size, formats, and metadata about the quality. Descriptive metadata are extremely important in cross-domain search. Data providers should not assume who the user will be. Therefore, we must be generous and provide as much metadata as possible, even if it seems unnecessary. In Aquarius, we will use specific tools for creating rich metadata. You can see some examples in the lower part of this slide. The third criterion is that metadata clearly and explicitly include the identifier of the data they describe. This is a simple principle but very critical to FAIR. Usually, the metadata and the dataset they describe are in separate files. The connection between them should be made explicitly by using in the metadata the globally unique and persistent identifier of the dataset. As outlined in the first principle, many repositories generate such identifiers for the deposited datasets, which can be used to establish these links between data and metadata. The fourth and final principle says that data and metadata should be registered in a searchable resource, in a search engine. This means that identifiers and rich metadata are important, but not enough to ensure that digital resources are findable online. But digital resources should be uploaded on a data repository, such as a data archive, a catalog, a portal, a data service. Repositories are infrastructures that collect, organize, archive, and provide access to data. Without the repositories, FAIR data can be lost if no one, humans or machines, can find them. You can see examples of repositories used in Aquarius here in the lower part of the slide. The next principle is for the accessibility. Once users find the data, they want to know how this can be accessed. Possibly the access includes authentication and authorization. The first criterion says that there should be no barriers to data access. Data must be retrievable through a clearly defined, standardized communication protocol without specialized or proprietary tools or unusual communication methods. Identifiers must support both machine and human access, regardless of whether data is open or restricted. Examples of such communication protocols are the HTTP or the FTP, which are the simplest ways for Internet users to retrieve data by simply clicking on a link. The first principle comes with two sub-criteria. The first says that to maximize data reuse, the data access protocol of the data repository should be free with no cost, should be open source and globally implementable. Open protocols lower access barriers, they ensure unrestricted access and enable anyone to implement them without cost. The second sub-criterion says that as fair data are not necessarily open or free, the access conditions should be clear and should be understood also by machines. Examples of licenses that are doing that are the common creative licenses. In Aquarius, this will be used. In cases of restricted data, accessibility requires authentication. Namely, the repository may require a user account for authentication and for setting up the user access rights in the system. Aquarius allows for an embargo period, but this should be justified in the data management plan and should be expired by the end of the project. This principle is focusing on the long-term availability of digital resources and ensures that metadata remains accessible even when the data itself is no longer available, either due to the design of the data stewardship system or due to an accidental deletion. Since the data may have been used, referenced or cited, it's essential that at least the metadata remains available to explain what existed. Additionally, if the data has been replaced by a newer or updated version, the metadata for the previous version should clearly indicate the existence of the new version and provide guidance on how to access it. The next principle is for interoperability. Interoperability is one of the most technical aspects of FAIR and means that data should be machine actionable. In other words, machines should easily read, use and combine it with other data for analysis and processing. The first principle says that humans and machines should be able to exchange, read and understand each other's data without requiring specialized algorithms or mappings, translators. Actually, this principle emphasizes that digital resources must use a machine-readable language with a clear defined structure to enable interpretation without mistakes. Without clear descriptors, it might be difficult for both humans and machines to combine and use data effectively, especially across disciplines or organizations. But using standardized knowledge representation, we ensure that machines can distinguish and interpret data correctly. What we need for that? We need metadata standards, we need control vocabularies, which are common terms to describe parameters, instrument, platforms, and so on. We need ontologies for finding data in different systems and linking them in various formats based on various concepts. We need open or standardized file formats like PDF, CSV or JPEG to ensure that data will remain accessible and reusable in the future. It makes data also more interoperable because I do not need any particular software to read the files. The second principle says that data and metadata use vocabularies that follow FAIR principles. Control vocabularies are terms or concepts that are carefully selected to adequately represent their domain content. In vocabularies, each term means just one thing. Simple labels like temperature or salinity are not enough. Humans and machines must be able to distinguish and resolve the intended meaning to avoid wrong interpretations and ensure correct data linking. By using vocabularies in data description, we achieve semantic interoperability. To support FAIR, vocabularies themselves must be findable, accessible, interoperable, and reusable. The third criterion says that data include qualified references to other data. Let's see what it is about. In FAIR, interoperability means that data and metadata are not isolated, but connected through qualified references. Qualified references are links that clearly specify the nature of relationship with other datasets. For example, if one dataset builds on another dataset, or if it is version 1 or version 2. Data should link in a meaningful way to external resources using standardized and interpretable relationships. As multi-metadata files can describe the same resource from different perspectives, it's important to clearly distinguish between the metadata files and the resources they describe. Let's see in the last principle, the reusability. As we have seen so far, the ultimate goal of FAIR is to optimize the reuse of data so that the data can be used for new research and innovation purposes. Reusability increases data and research transparency. To achieve this, metadata in data should be well described. The first principle says that data are richly described with a plurality of accurate and relevant attributes. The criterion emphasizes the importance of not only providing metadata for data discovery, but also richly describing the context in which the data was generated. For example, the experimental protocols, the manufacturer and brand of the machine or sensor that created the data, the species used, and so on. In this way, it will be much easier to find and reuse data if there are many labels attached to it. This criterion is related to the previous second principle of findability, which was saying that data are described with rich metadata. But this one, for the reusability, is focusing on the ability of a user, machine or human, to decide if the data is actually useful in a particular context. The principle also stresses that data publishers should not attempt to predict the data user's identity and needs. We do not know who is going to use the data and for what purpose. Therefore, data publishers should be as generous as possible and offer a plurality of comprehensive metadata, even if some information seems irrelevant. Here, in this bulleted list on the bottom of this slide, there are some main key points on what we should take into consideration when we prepare metadata. This is not an exhaustive list, but it is indicative. We should describe the scope of the data, why they were collected, and also describe any limitations if exist. We should specify the date, the laboratory conditions, the data generator, the parameter settings, and the software versions. We should indicate whether the data is raw or processed, to ensure that variables' names are explained, or explain if they are following controlled vocabularies, and document the versions of the archived data. This sub-principle is about how to use the data, what users can do with it. This criterion concerns the legal interoperability, while the previous ones cover elements of technical interoperability. Actually, a data license is a legal arrangement between the creator of the data and the user of the data, specifying what users can do with the data. The usage license should clearly describe the usage rights to avoid ambiguity and limited data reuse, because with no license, no one can reuse our data in the way we want. In Aquarius, the CC BY license will be used by default. This one means that the users are free to use the data, share, change them, but it is mandatory to give proper credits to the creator. The second sub-principle states that for others to reuse my data, they should know where the data came from. They need to know their origin, their history, who to cite, how I wish to be acknowledged, and so on. The provenance metadata help to show whether data are suitable for reuse and explain how the data were processed. Detailed provenance include information on who generated or collected it, proper acknowledgement and credits, how has it been processed, has it been published before, does it include modified or completed from others' data. And finally, the third sub-principle, which says that it is easier to reuse datasets if they are similar in terms of same data type, if data organized in a standardized way and in well-established and sustainable file formats, and if they have consistent metadata using common templates and vocabularies. We should remember that if community standards or best practices for data archiving and sharing exist, then we should follow them. We also should have in mind two things concerning the data quality and reliability. FAIR principles do not address data quality issues, and data's reliability depends on who is using it and for what purpose. And now, a very few words for the FAIR extensions. So far, we saw that FAIR principles are a data-oriented framework that describes those data characteristics that enable sharing and reuse. And this, as we explained, is the basis of good data management and stewardship practices. However, FAIR principles do not address issues related with the rights of the people that data represent and for which purpose data are used. To address the issue, and particularly indigenous people and data, FAIR principles were extended and complemented with the CARE principles, which are a guide for open data projects for including indigenous people's rights and interests. But in principle, the CARE concept should be adopted in all cases where the people who participate in a project and provide data can have some moral rights in the information they contribute. The principles formulated in 2019 by the Global Indigenous Data Alliance, that is part of the Research Data Alliance. CARE stands for collective benefit, meaning that data should be used to support indigenous communities. Authority to control, meaning that indigenous people have the right to govern data about them. Responsibility, we should use data in a responsible and in a respectful way. And ethics, use of data should minimize harm and promote justice. The second upgrade is for the trust principles. We saw that FAIR defined the properties of data and metadata for being findable, accessible, interoperable, and reusable. FAIR data can have a great impact on scientific community, and therefore it is needed to be deposited into data repositories that we can trust. This is what trust principles are doing. They describe the characteristics of data repositories which are responsible for the stewardship of research data. By stewardship, we mean managing data to make them accessible, usable, safe, and trusted on the long term. So, trust is a set of principles focused on the design, governance, and maintenance of repositories, providing, as I just said, guidance on how to build and sustain trustworthy data repositories. Discussions on trust principles originated within Research Data Alliance in 2019, with 2 white paper releases the same year. The final version published in the Nature Scientific Data Journal in 2020. Trust stands for transparency, meaning repositories should be transparent in what services they provide, with clear documentation of data management policies and practices. Responsibility is the data repository's commitment to provide reliable data services. User focus is the repository's commitment to provide services to meet the user's needs. Sustainability is the capability to support long-term data preservation and use. And technology is the infrastructure and the capabilities to support the operations of the repositories. This was a generic overview of FAIR data and FAIR principles to help Aquarius scientific teams of transnational access projects to understand what is behind FAIR and what is expected. So let's conclude this presentation with how Aquarius is managing the data fairness. Remember that at the start of this presentation, we said that the Horizon Europe funding projects have to provide fair data in compliance with the European Open Science Strategy. For that reason, Aquarius project has adopted an open data policy and is following a dedicated data management approach for managing and publishing data, products and knowledge in line with the FAIR principles. This data management strategy will ensure the quality assurance, the long-term stewardship and wide access and use of the collected data within the Aquarius project. How this will be done? By integrating the data into 5 European data management infrastructures that meet the FAIR requirements. You can see these infrastructures on the screen and more detailed information on the deliverable of the project about the data management plan. In addition, these systems are supporting and contributing to European marine data services infrastructures and initiatives such as IMODNET, Copernicus Marine and the Digital Twin of the Oceans. Therefore, the TA projects have to adopt the Aquarius approach, which means align to and adopt the European data management infrastructures standards, tools and best practices for making their data fair. To accomplish all this, the TA projects will implement their data management plans since their start. The data management plans specify how the collected data will be managed both during and after the project's end, and how to implement FAIR. The initial plans will be reviewed and refined with the support and advice of expert data centers, which are mainly national oceanographic data centers. Aquarius project will offer training and support to the scientific teams on applying FAIR data management standards using appropriate relevant tools and services. Also, Aquarius will facilitate the sharing and integration of data and metadata into the European data management infrastructures I mentioned before. Summarizing, these bullets below in the blue frame contain what will be needed from the transnational access project's scientific teams. It will be needed to deliver data that follow the formats of the European data management infrastructures, to provide rich metadata identifiers and quality controlled data, to use common vocabularies to describe their data, to use the Aquarius ingestion mechanism for data delivery, to use open science platforms and catalogs for the published results and scientific papers, such as Zenodo or Blue Cloud catalog that is connected to the European Open Science Cloud. Thank you very much for watching this presentation.